Hi, and welcome to a Calculus 1 video on the product and quotient rules for differentiation. This will be the second part of a multi-part series here. We're just going to, in this video, work with a second derivative and how just because it has a fraction bar does not mean you have to use the quotient rule, and also looking at some other derivatives where we are given the derivative value to begin with. So let's take a look at some of these examples. All right, in this first example here that we're going to go through in this video, you are asked to find f double prime of x, and that is notation for the second derivative. So you're going to find the first derivative and then do the derivative again. That will get you to the second derivative. And here we are given our function that we are working with. Now, just because you see a fraction bar here does not mean that you have to use the quotient rule. But let's take a look at what happens if I do. So I'm just going to take this green piece right here, just 2 over x, off to the side for a second and show you what happens. So if my function is something like 2 over x and I decide to use the quotient rule, I would say f prime of x, because here's my derivative, and it's low, so that would be x, d high, and the derivative of the high would be 0. Right, because derivative of 2 would be 0, minus the high, which is 2, d low, so now I'm doing the derivative of the denominator, which would be 1, all over the low squared. And now I will just mention that anytime you have a 0 in your derivative, maybe it is a possibility that that rule was not needed. That maybe you could have done it in a little bit more efficient of manner. So if I simplify this just to kind of see what I should be getting, this becomes negative 2 over x squared. Well, how else could I think of 2 over x, for example? Well, we did this problem when all we knew was power rule, because 2 over x, if I go through a rewrite here, is simply f of x. Right? I'm just doing a rewrite. I'm not doing any calculus yet. The rewrite would be 2 times x to the negative 1 if we just use negative exponents. So my derivative, I'll just use power rule. I'll bring down the exponent and multiply, keep my base the same, subtract 1 from the exponent. And again, if I chose to rewrite that part, that's exactly what it would look like. So those are equivalent. So I do have choices. When I'm doing the derivative, you will get to the same end, right? But sometimes you're going to make small computation errors if you have more computation to work with. Or we might forget that the derivative of 2 was 0, something like that. So I'm going to do a rewrite here before I start so that I can see that this is just really power rule. So I'm going to say 2 minus 2x to the negative 1. And what I really don't want you to see is 2 minus 2, because that's what maybe is drawing attention to your eyes. Remember, we can't combine like terms because we certainly couldn't in the beginning, so I can't now either just because I wrote it with negative exponents. So, because again, that's like x to the 0, right? So my first derivative, if I just use power rule, again, if it's like x to the 0, because this is a constant of 2, bring down your exponent of 0, that term becomes 0. I don't have to write down 0. But then this term of negative 2 or minus 2 x to the negative 1 is going to become positive 2. Keep your base the same, x, and subtract 1, negative 2. And then it asks for the second derivative. So I do not do a rewrite and get rid of my negative exponents because I just want to use power rule. So I'm going to go again. And I'm going to do the derivative one more time, which makes it the second derivative. So f double prime of x equals, bring down your exponent, keep your base the same. Right, so I brought down my exponent and multiplied, keep my base the same, and subtract 1 from your exponent. Please do be careful when you're subtracting 1 from these negative exponents. Negative 2 minus 1 gets you that negative 3. And if you wanted to do a rewrite of that f double prime, you certainly can. If you're doing something with this derivative, I highly recommend it. If you're calculating or computing or looking for domain restrictions, all of that, I highly recommend a rewrite because now I can see my domain restrictions a little bit better. But certainly if all you're doing is finding the derivative, this isn't 100% necessary. You do have to make sure that you know these two are equivalent back and forth. A negative coefficient does not move, the negative exponent did. Okay, and let's take a look at this next one, number 5. Now again, I know I was suggesting you don't have to always use the quotient rule, but let's take a look at how the quotient rule can help us, but maybe let's look at doing a rewrite first, just like we did in the previous problem, because we could only use power rule then. Let's take a look at a rewrite and see how that helps us. For example, I'm going to take this cube root of x right here and replace that with x to the 1/3. Remember, power over root. So that way I can see everything as a power of x. So here's my rewrite. So h of x equals, I have x to the 4th times the e to the x plus 4. So that's going to be a product rule right there. Minus x to the 1/3, and that's all over x squared. Now I hope, especially as you're doing this rewrite, you might have noticed, gosh, that's a lot of x's that I'm writing down. Well, sure, I can separate and reduce, meaning I can divide every term I have in my numerator by x squared. So you can look at it like so, right, where I have separated the two terms out because they each have to be divided by x squared. That's one way to look at this. You can also look at this as a product of the numerator times x to the -2 if you bring that up and distribute it. But I like this way. Kind of shows you what you're doing as well. I'm still at h of x, so I'm going to divide that in. So I can divide in x to the 4th by x squared, so that leaves me with x squared e to the x plus 4. That's going to still be product rule. Minus, well, keep your base the same and subtract your exponents. So 1/3 minus 2, or 1/3 minus 6/3 is going to give me a -5/3. And again, if you ever want to see if this h of x is equivalent to your original h of x, go ahead and put in some random number like 2.9 or 3.85. Just don't use 0, 1s, or 2s because those can give you some false positives every now and then. But I go ahead and put in some random number for x and see if you get the same value when you substitute that in. And I let my calculator do that part, by the way. Okay, so then all I'm doing here is product rule. This is a product. I don't have quotient rule at all. So again, just because we saw that fraction bar in the original problem does not mean that I'm stuck with quotient rule. So after my rewrite, I can see that it's just product. So now here's my derivative. So note, here's my derivative or calculus step. So I'll do the derivative of x squared, which is 2x, and I'm going to leave e to the x plus 4 factor alone, plus, now I'm going to leave x squared alone, and we briefly talked about this so far. The derivative of e to the x plus 4 for right now is e to the x plus 4. It is itself. And then my last term here is minus x to the -5/3. So if I bring down that exponent and multiply, this will become plus 5/3 times x to the, and if I subtract 1, again, be very careful with your negative exponents. -5/3 and a -3/3 or a -1 would be -8/3. And you can go ahead and leave your answer in this form. You're not doing anything necessarily with this derivative right now. You are just trying to find the derivative. Let me show you the alternative here of if you just looked at it the way it started and used quotient rule, how that would look. So let me get rid of some of this other stuff here so I can see a clean h of x. So if I just used quotient rule with no rewrite, let's see if it looks a little bit better for us or not. So h prime of x equals, so the benefit to this is I'm not doing a whole bunch of algebra first or rewrites first. I'm going straight to my calculus, but the drawback is going to become in the complexity sometimes of that calculus. So low, so that'll be x squared, d high, and here's where I have to be really careful. When I'm doing the derivative of that high, I have a product within this high. So here's my overall parentheses, and I need to honor that. So it's low times all of this d high here. So that will be x to the fourth derivative is 4x cubed. Leave the e to the x plus 4 alone. Plus, leave the x to the fourth alone. And the derivative of e to the x plus 4 is e to the x plus 4. Then I have minus, and I'll still want to look at that as x to the 1/3, so I can power rule that. So this will be minus 1/3 x, and if you subtract 1 from 1/3, you get negative 2/3. That's just low d high. Okay, now keep going. So I'm going to make this smaller here so I can fit it. Minus high, the whole thing, d low, so 2x, all over low squared. So maybe here's my point. For sure, would find this derivative here more difficult to simplify than the original. So if I couldn't simplify the original, I probably may have a really, really hard time simplifying that quotient rule derivative. So a lot of mistakes can happen in that. So I highly recommend a rewrite first if you can. Again, it's that idea of look at a problem first and take a second to pause and identify, would I benefit at all from a rewrite? And don't be afraid to just try it and see. All right, now let's look at what's next. Okay, so let's look at this other example here. These are kind of unique. So in this example, I'm going to give you different values. So I'm going to say, suppose f of 2 equals negative 4, and g of 2 equals 5, f prime of 2 equals negative 1, and g prime of 2 equals 2. And I'm asking you to find h prime of 2 in every single problem, and then I define h of x in each of these 4 scenarios. So let's go through these scenarios one by one. So the first scenario says h of x is defined to be 3 times the function f minus 5 times the function g. So this derivative for h prime of x is going to be 3 because coefficients stay, right? It's still going to be 3 times as much of my derivative, which all I know right now is f prime of x. There's no product rule, quotient rule, or anything associated with that. The derivative of f is f prime. Minus, again, coefficients will stay, 5 g prime of x. And what I want you to get in the habit of doing is, now that I'm trying to find h prime of 2, is I'm going to write my h prime of x, the step I have above, but everywhere I have an x, I'm going to substitute in a 2. Promise, I promise, I promise. There is a reason for that step. It is not just wasted energy. Sometimes, for example, maybe you don't know f prime of 2, but you know all the other unknowns at this time. So I have 3 unknowns. I can know any of the 2 and find the third. So you don't necessarily always solve for h prime of 2. So please go through that rewrite. So this will be 3 times, and f prime of 2 is given up here in green. F prime of 2 is negative 1. Minus 5 times g prime of 2 was given up there to be a 2. So h prime of 2 is negative 3 minus 10, negative 13. So my slope of my tangent line of the function h at x equals 2 is negative 13. So now let's get into some of these product and quotients. Now in part B, h is going to be defined as a product, f times g. So I have to remember my product rule. So I will say h prime of x, separate that there. And if you remember product rule, we're going to do the derivative one at a time. So I'm going to do the derivative of f first, so that'll be f prime of x. And I'm going to multiply that by g of x. Remember, you just leave g alone. Plus, now I will leave f of x alone. And now I will multiply that by the derivative of g, which is g prime of x. So again, h prime, since h is defined to be a product, I have to use a product rule. And I have f times g, so that will be f prime g plus f g prime. And again, order is not too critical here because you're adding. So now I'll substitute in a 2 everywhere I see an x. Again, I promise that step will be worth it. And then I'll evaluate based on the given values that I have up above. So f prime of 2 is the green value of -1. And I'm multiplying that by g of 2. Make sure you're looking at g of 2 and not g prime of 2. So that is 5. Plus f of 2, which is the yellow highlight there. So -4 times g prime of 2, which was 2. Again, they're all defined for me in the beginning part of the problem. I'm not making any of these numbers up. So now it's just the computation of that. So h prime of 2 is -5 and -8. Again, -13, super coincidental. All right, so let's look at C. Now C and D should both look very similar to each other. I have to keep these values on the screen too. So let me make sure I can see f of 2 and g of 2, etc. So for h of x, I can see that I have to use quotient rule right now. You know, once we learn chain rule later, maybe you have other options, but for right now, it's quotient rule. And in D, I'm using quotient as well. Now for part D, it might look a little bit trickier because of the 1 plus, and in fact, it will get a little bit trickier, but not too bad. Okay, this is kind of in my way here. So hopefully you got all that, or rewind the video. It's the beauty of a video, right? All right, so let's first define h prime of x just based on this f and g using the quotient rule. So h prime of x is going to be low, so g of x, d high, so the derivative of the high would be the derivative of my numerator, f prime of x, minus the high, f of x, d low, and derivative of low, derivative of g of x, is just g prime of x, all over the low g of x squared. Notice not one time have I said the u's and the v's, right? Most of us will learn the quotient rule is low, d high, minus high, d low, all over low squared. The other thing I think is important to note is that because g of x, the x is in parentheses, I like to put the whole g of x in a bracket. That way I kind of know that's staying together. So I'll substitute all these x's with 2's. Be careful as you're copying this down, because if you miss a prime symbol, the whole thing is going to be wrong because you'll have the wrong value. Okay, the other way that I kind of like to see, am I doing the quotient rule correctly, is it starts low d high minus high d low. So it starts with low and it's all over low squared. If I could have divided those factors out or sort of simplified that quotient rule, I would have done that from the beginning and I wouldn't put that in the rule, right? So the whole idea here is that's just a check to myself that I'm doing the quotient rule in the right order. So that's what I like to look at there. Okay, so now I'm going to find those 4 values based on the 4 values that we were given above, right? So h prime of 2 is g of 2, which is 5, times f prime of 2, which is -1. F of 2 is -4. Watch your signs here. G prime of 2 is 2. All over g of 2, which is 5 squared. So h prime of 2 is -5 plus 8, right? So 3 over 25. Okay, last one here. So you may want to see, I think I can do this one, right? I think I can apply the quotient rule. It's very similar to the previous one. So you may want to pause the video and try just the first step yourself. Try to just set up h prime of x equals, right? So just say h prime of x equals, try to apply the quotient rule, and then go ahead and hit play when you've done that, and let's check your work. All right, so hopefully here you are. Here's the low times d high minus the high g of x times d low. And I will admit right there, that d low part, I'll put it in yellow, is the part where people tend to make an error if there's an error made. The derivative of the low, derivative of 1 is 0, and derivative of f of x is f prime. So low d high minus high d low all over low, the whole thing, squared. So hopefully that's what you have. I'm sure it is. I'll substitute in the 2. And now that I have the 2 in there, I'll go ahead and figure out what these values are. So I need to put them back on my screen here for a second because I can't see them. So 1 plus f of 2 is negative 4. So I'm going to say 1 minus 4 times g prime of 2, which is that pink 2, minus g of 2, which was 5, and f prime of 2, which is negative 1, all over, those could be parentheses now, that would be fine. 1 plus f of 2, well again I've done it, up here with the 1 minus 4, but I have 1 plus f of 2, and f of 2 is negative 4, so I'll just say 1 minus 4, quantity squared, and I'm running out of room. So this is negative 3 times 2, so negative 6 plus 5 all over 9. So it should be h prime of 2 equals negative 1/9. The reason that some faculty like these questions, or some students maybe get frustrated by these questions, is there's nothing that you can really check on your calculator using your graph, or checking this any other way other than applying the quotient rule correctly and then finding those values. So it's a really good assessment of, are you understanding the quotient rule and able to evaluate without error to the end. So I hope you found this video helpful. More derivatives to come. Hope you're enjoying them.